Hey, hi all, welcome to the channel. Hope all is well at your end. So today we will talk about one important concept of any relational database management system, which is joins. Okay, so using joins, we can join multiple tables and we can pull large amount of data. So in this particular video, we will try to understand what exactly joins, what are different types of joins. Okay, so let's start this particular video. But before that, if you are new to the channel, please go ahead and subscribe it. Okay. And please make sure to like, subscribe and share this particular video in order to reach it to wider audience. So let's talk about joins. Okay, so joins are basically used to combine rows from two or more tables. Okay, based on common column or related column between them. So getting result from more than one table is known as join. Okay, so join help us in many ways. Okay, it helps us in maintaining data integrity. It ensures that whatever results we are getting after joining multiple tables, it should provide us accurate or correct results. Okay. So some common uses of joins are combining related data, filtering data, then aggregate data, complex report creations, and this is also useful for analyzing hierarchical data. Okay. So let's talk about different types of joins. Okay, so first we have got inner joins. Okay, so this basically returns record that have matching values in both the tables. Okay, so let's look at the syntax. Okay, select A dot column 1, B dot column 2 from table 1 A, inner join table 2 B on A dot column is equal to B dot column. Okay, so what exactly it's doing? Okay, it's basically combining two tables, table 1 and table 2, okay, on the basis of common column, which is here common underscore column between both the tables, okay. So on this particular condition, we are basically joining these two tables, table 1 and table 2, okay. So let's try to understand this join using some examples, okay. So let's say we have got two tables, EMP and DAPT, okay. In EMP, we have got three columns, EMP-NO, ename and DAPT-NO, okay. And in DAPT table, we have got DAPT-NO, dname and LOC, okay. Now, let's look at the first example, okay. Display the employee name with their respective department name, okay. Now, in this particular example, we'll have to join these two tables, okay, because employee name is not there in department table, but department name is not there in EMP table, okay. So in order to meet this particular business requirement, we'll have to join these two tables, okay. So this is the query for the same. Select EMP dot EMP-NO, comma EMP dot ename, comma DAPT dot dname from EMP, comma DAPT, where EMP dot DAPT-NO is equal to DAPT dot DAPT-NO, okay. So here DAPT-NO is basically a common column between these two tables, okay. So using this particular column, we can join these two tables, okay. So here EMP.DAPT-NO is equal to DAPT.DAPT-NO, okay. This is basically a join condition, okay. Now let's look at the second example, okay. Display the employee names, those are working in New York, okay. So again here employee name exists in employee table, okay. But department name and the location of department that exists in department table, okay. So in order to achieve the business requirement, we'll have to join these two tables, okay. So query for the same is select EMP.EMP-NO, EMP.ename from EMP, comma DAPT, where EMP.DAPT-NO is equal to DAPT.DAPT-NO and DAPT.LOC is equal to New York. Okay, so this is how we can join two tables, okay, and which will basically retrieve common values from both the table, and that is known as inner join, okay. Next we have outer joins, okay. So outer joins give us a result inner join plus rows which does not have any direct match with the other table, okay. So there are different types of outer joins, okay. First we have got left join or left outer join, okay. So this basically returns all records from the left table and matched records from a right table, okay. If there is no match, nulls will be written for columns for the right table, okay. Syntax for the same is select A dot column 1, comma B dot column 2 from table 1 A left join table 2 B on A dot common column is equal to B dot common column. Okay. So left join ensures that whatever different records are there in left table, that has to be present in your result. Okay. Next we have right join or right auto join. Okay. This is just opposite of left join. Okay. This basically returns all records from the right table. Okay. And match records from the left table. Okay. If there is no match, null will be written for columns from the left table. Okay. So syntax is almost the same, only in place of left join we'll have right join. Okay. So right joins ensures that all the records from the right table has to be present in your result. Okay. If there is any direct match with the left table, then those columns values will come in your result. Okay. If there is no direct match, then null will be represented in those columns. Okay. Next we have full auto join. This is basically a combination of left auto join and right auto join. Okay. This returns all records when there is a match in either left or right side of table. Okay. And non-matching rows will have null. Okay. So syntax is the same. Only the thing is that in place of left and right join, we'll have full outer join. Okay. Let's try to understand left join using one example. Okay. So we have got two tables, student and marks. Okay. In student, we have got two columns, roll underscore number and student underscore name. In marks, we have got two columns, roll underscore number and marks. Okay. Just notice one thing here. Okay. So for roll number 12 and 24, we don't have any entry in the marks table. Okay. Similarly, for roll number 30, we don't have any entry in the student table. Okay. Now let's see how we can retrieve records using left join. Okay. So this is the query. Okay. Select as dot student underscore name m dot marks as dot roll underscore number. Okay. We have given it alias stud underscore roll underscore number. Okay. m dot roll underscore number. Here alias is marks underscore roll underscore number. Okay. From student s is alias here. Okay. Left join marks m on s dot roll number is equal to m dot roll number. Okay. Now what will be the outcome of this particular query? Okay. So here we are using left join. Okay. It means all the records from the left table has to be present in our result. Okay. So here student is basically a left table. Okay. So it means all the records from the student table should come in our result. Okay. If there is any direct match with the marks table, then those column values will also come. If there is no direct match, then null will be come in the result. Okay. So in this particular case, all the records from the student has to be there in our outcome. Okay. For roll number 12 and 24, we don't have any direct match with the marks table. Okay. So for these two rows, we'll have null values against the marks and roll number column. Okay. So let's see the outcome. Okay. So this will be the result. Okay. So in this particular result, we are seeing all the rows from the student table. Okay. For roll number 12 and 24. Okay. We don't have any direct match in marks table. So for marks and marks underscore roll number column, we have null values. Okay. So this is the example of left join or left auto join. Okay. Now let's talk about right join or right auto join. Okay. So we have got similar set of tables. Okay. Now let's see how we can apply right joins here. Okay. So the same query, the only thing is that in place of left join, here we have right join. Okay. Now what will be the outcome of this particular query? Okay. So we are applying here right join. Okay. It means all the records from the right table has to be present in our result. Okay. So here basically marks is our right table. Okay. It means all the records from the marks table has to be present in our result. Okay. So outcome for the same is, okay, like this. Okay. So we'll have all the roll number for the marks table. Okay. for roll number 30, we don't have any direct match in student table. Okay, so for this one, under student underscore name and stud underscore roll number columns, we are getting null values. Okay, so right joins ensures that all the records from the right table has to be present in our result. Okay, now let's talk about full auto join. Okay, so the same example, okay, and the same query. Okay, the only thing is that in place of left and right join, we are applying here full auto join. Okay, now what will be the outcome? Okay, so full auto join ensures that all the records from the left table has to be present in the result, as well as all the records from the right table has to be present in the result. Okay, and the records where we don't have any direct match, okay, for those columns, null can be displayed. Okay, so the outcome will be here. Okay, so you will be able to see all the records from the left table, okay, as well as all the records from the right table. Okay, and for Deepak and Priyank, okay, here you would be able to see null. Okay, because here we are applying full auto join. Okay, and then so this is basically a part of left join. Okay, and now for this 30, roll number 30, okay, that will be outcome of your right join. Okay, indirect, it will be part of full auto join. Okay, so here this particular result is coming through right outer join. Okay, so this is how full auto joins incorporated left join as well as right outer joins. Okay, now let's talk about cross joins. Okay, so cross join is basically a Cartesian product. Okay, when we specify two tables without any join conditions, then normally this particular join gets applied. Okay, syntax for the same is select A dot column 1 comma B dot column 2 from table 1A cross join table 2B. Okay, so here we are not specifying any sort of join condition. Okay, so whatever join will be applied, that will be called as a cross join. Okay, so in any Cartesian products, the number of rows is basically number of rows in one table, okay, multiplied by number of rows in other table. Okay, this is how we can get total number of rows after applying Cartesian product. Okay, so in our example, okay, the same example, only in place of join we have mentioned here cross join. Okay, if we use the same table whatever we discussed in earlier slide, okay, so the outcome will be, we'll get 20 rows. Okay, because in one table we have got, in student table we have got 5 rows, in marks table we have got 4 rows. Okay, so the outcome will be 4 multiplied by 5, which will be 20. Okay, and this will look like this. Okay, so it will basically form a Cartesian product of two tables. Okay, now let's talk about self join. Okay, so self join is basically used to join a table with itself. Okay, it is basically used in order to compare rows within the same table. Okay, so what basically database engine does, it basically opens same table in two memory space. Okay, and then start comparing different rows. Okay, so basically the syntax of self join is select A dot column 1 comma B dot column 1 from table 1A table 1B, where A dot common column is equal to B dot common column. Okay, let's look at the example. Okay, let's say we have got this table. Okay, employee, we have got 3 columns: EMP underscore name, EMP underscore number, manager underscore number. Okay, now the requirement here is that we'll have to list employee names with their respective manager names. Okay, in such cases, what will be the query? Okay, so we can achieve this particular objective using self join. Okay, so the query will be select E.emp underscore name as employee, M.emp underscore name as manager from EMPE, okay, and EMPM. Okay, so here basically we are opening same table EMP with two alias name, okay, E and M. Okay, now the join condition here is E.mgrno is equal to M.empno. Okay, so this will give us this kind of output, okay, where we'll be able to get employee as well as their manager name. Okay. Now let's try to understand this particular query. Okay, just look at this particular join condition. E.mgrno is equal to m.empno. Okay, it means for each and every employee, this condition will be evaluated. Now, whatever values is stored under mgr_no, okay, that is basically an employee number. Okay. So at the end of the day, manager is also an employee of the organization. Okay. So in order to get the manager name, we'll have to get the employee name. Okay. So this particular join condition will iterate for each and every row of employee table. Okay. And for each and every row, we'll get manager number. Okay. And from manager number, we'll get their, like employee name. Okay. So we'll stop here. Hope you would have liked this particular video. Okay. Please like, subscribe and share this particular video in order to reach it to wider audience. I'll see you in the next video. Till then, goodbye. Thank you. Keep watching.